Okay, before I show before we try out the tool, also mentioned I did do some work when I was down with the missing gallbladder. It's not missing; they took it out, threw it away, burned it, I hope. Anyway, I modified my Dorian tool post so it's indexable. You know, Dorian and Aloris both make indexable tool posts. There's the multi-fix stuff, which all of which are pretty expensive. The Dorian and Aloris tool posts have 4 holders, and they're not really quick change. You have to take a bolt out. They're made for production where you can set up 4 tools and index them around. The multi-fix is quick change. It's lovely, but I have like 25 holders, and to buy that many, and I can't make those. You can make these kind pretty easy. So I mean, the investment to replace all of this would have been a few $1,000s, and I just can't justify that. Not for my needs. So a while back, 6 months ago, I don't know more, I made this quick change nut. It was inspired by John Mills' Double Boost videos over in the UK, and if you don't watch his channel, you probably, it's great. And of course, if you're watching mine, you probably have seen his. Anyway, so you know, that's this part loosens up, and so what I did is take this off and show you real quick. Basically I put some spring-loaded ball bearings in the bottom, and some dimples in the tool post. So hopefully they won't fly out. They should be okay. They're in there with some lithium grease. So let me go see if that shows up on camera. So what I did was the Dorian tool posts come with a couple of holes in the T-slot and 4 holes in here. They're all 10 millimeter. And that's for pinning it to the T-nut, which is great if your tool post is square or your compound is square, but I keep mine at 30 degrees, so for cutting threads. So I wanted to be able to index it repeatably, but still, you know, have it land on 30. So I played around with my CAD program, you know, took some measurements on here, figured out how much space we had. So this is a 1.7 inch diameter circle. These are 1/4 inch ball bearings, and I cut these with a 1/4 inch ball, solid carbide ball end mill, because these are through hardened. There's enough meat on here to do this. These are 0.062 deep, which is 1/4 of the diameter of the ball, so that way it seats in there good, but it'll slide out pretty easily. They almost overlap. There's just a few thousandths between them, clearance, so that worked out just right. I decided to use 2 bearings and 2 springs. I had a whole bag full of springs, a couple of hundred of them from an old purchase. So if anybody that's watching this wants to make one of these and you need some springs, let me know. You can have a few. The other thing, and I don't know if this will show up, is I put a couple of grub screws in here, and that locks the T-nut from sliding, just to make the indexing more repeatable so it doesn't move around that direction. But it's not perfect. It doesn't, you know, if you don't line it up just right, the ball, you know, it won't lock down exactly right, but it works pretty good. So we'll get those lined back up. Put this on, I'll show you real quick. And you'll be able to hear it index around as the balls drop into the D10s. And they're just hard chrome steel balls, quarter inch. So you can probably hear it. It thunks in there pretty good. But in the 30 degree, this is parallel with this, and obviously I turn it over. So 24 dimples. That gives it 15 degree increments. So it's nice because if I want to go 45 degrees to put a chamfer on, I can. You know, there's 15, 30, 45, and it comes back to 90. And you can see it wiggles just a hair. So if you get it right exactly, you just kind of wiggle it in and push it down and hold it and then snug it up. So it's probably within, you know, half a degree, maybe a little less. If you need it super good, you're going to have to dial it in anyway, which, you know, if you're parting or something, I generally run the tailstock quill out and just line it up on that, and that gets it really, really close. So let's put our tool bit in a holder and give it a try, because I've never used it. I bought those inserts in the holder, and this is be our first run. So let me, so we got I think this will show it. We got just a chunk of 1 inch. I think it's 1018 coal roll, might even be hot roll, I don't know. 1018 mild steel. I've already done some other whacking on this end. I'm just going to turn it around. We'll just turn a little off of this just to see how it goes. Just a little of it. I'm not going to go out and grab a big chunk of bar stock just for this. We'll snug that up. I don't even care how true it is. Let's see here. That one is 3/4, so we need a pretty good sized holder. All right, we'll use this one, and I think this one takes 5mm screws. And we'll get our freshly modified tool holder. I haven't even put the insert in after playing with it. So let's get this in here. I'm just happy it goes. Ah. Right, so that's good. Gonna back our screws out a little bit here. Okay, so there's that. We'll set our center height with their handy little gauge here. Probably won't show up very good, but I'm not going to move the camera to mess with it. That's real close. Good enough. So like I said, I've never used one of these inserts before. I picked these up for a really good deal. It might even be a bit overkill for the size of this lathe, but we'll give it a shot. Let's move over here and we'll see how it cuts. So let's see, this is 1 inch mild steel carbide. Yeah, we're gonna run this at probably about 600-700 RPM maybe. So there's 600. And let's turn up the feed a little bit. So it's 3-degree relief, so we should be able to face and turn. Seems to be holding in there. Let's give it an actual cut. Yeah, look at there. We have no troubles. Yeah, we even hit center. So face is good. Let's see. We'll go there. Try 50 thousandths to start with. See what happens. Could probably go a little harder. The chips are still silver, but it's mild. It's, you know, it's 1018. It doesn't give a great finish usually anyway, but it's not terrible for roughing, and it's certainly not moving. I think our little fix worked out all right. Let's see here. Where's our feed at? We're on, let's see here, that looks like ECU. That wasn't much feed, that was 1/4. So let's go up to 4 thousandths per rev. This should give it a A little more work to do. We'll take another 50 thousandths, but we'll get about triple the 4 thousandths feed rate. It might be a little more than 4. No issues though. A little rougher. Let's turn it up a little bit. See what we can go. Let's take it up to let's go 800, and let's take 100 thousandths off, 50 thousandths depth of cut. It might protest. Let's see. No, they're blue. I think the belts are slipping, but well, we actually got a lot better finish. It's a little rough, but it's a lot better than what it was. It took that without any trouble. The insert's taking it, no trouble at all. Might be a little bit much. Back the feed down just 1. Take another 100. And a little bit lower feed rate and see how that lights. That's just about right, I think, for roughing. That about stalled it at 200. He didn't like that. Not bad. So our little cheap holder and inserts. Looks like it works pretty good. It didn't beat it up too bad. I just did it dry. It's a little build up on the edge. You can turn color a little. Not so bad. But I got a couple of boxes of them for really cheap. So that's why I bought them. So I think this is going to be a success. I almost forgot to say, if you do attempt something like this, when I clamped it in the vise upside down, and I didn't take it all apart, so I only had a little bit to hold on to. These are nice and parallel. That's not a problem. But because you don't have a whole lot to hold on to, it doesn't sit perfectly straight in the vise, especially since it's sitting on this. So I ended up putting a test indicator and going X and Y, and just tapping it in with a chunk of copper until I had it within a couple tenths in each direction, and then found the center to do that. That just something to keep in mind. They're not super critical, but you want them all the same depth. So if you really want to level, do a proper job. This is the stock Chinese one, and you can see that these slots went all the way through. So there's just you couldn't do it on one of these unless you made some kind of plate to go on there. We'll say it was the size of the base at the bottom of the dovetails. I don't know how good that would work out, but you'd probably want to pin it somehow or something so it wouldn't move. You'd maybe 100 thousandths thick or a little more, a couple, 2.5 mil, something like that. But the amount of metal you have there, you just couldn't get 24 dimples that size in there. You could go something smaller, but then it wouldn't index as well, and it's already, not super high precision anyway. But just wanted to show that real quick, and that's it. Anyway, if you like my videos, give us a thumbs up and subscribe, and love to hear some comments. I've got a couple hopefully cool projects coming up. I talked a while back about making a balancing roller type balancer for chucks and whatnot. That was going to start, and then I had a lot of work to do, and then I got a little sick. So that's still in the works. I have all the materials. I have everything I need, other than I haven't had time to do it or ability. The other thing I'm going to do is I've got a friend that he's been a machinist for 40 years. He's really good. But he's been telling me for 10 years I need to make some special vice jaws with an idea of his that have a bunch of dowel pins in there, so you don't need parallels and stops for a lot of things, and it's very repeatable. And he convinced me yesterday, so we're gonna make Randy's vice jaws. I don't have them. I did order some 4140 pre-hardened steel to make those out of, so that'll be coming up hopefully in the next couple weeks as well. Anyway, thanks very much for watching, and y'all have a great day. Bye.